What you're looking at is one of the most studied, well-documented wind farms in southwestern Ontario. Located between Lake St. Clair and Lake Erie in the municipality of Chatham, Kent, the North Kent Wind Project is a partnership between majority owners Pattern Development and Samsung Renewable Energy.
So the North Kent Wind Project is a 100 megawatt project which will supply approximately 35,000 homes. We want to have a reputation that when we come into a community, we do it the right way, and we develop and construct very responsibly and are responsive to the concerns of that community.
Over the life of the project, the 34 wind turbines, all of them made in Ontario, will inject more than $40 million in economic benefits to the Chatham-Kent economy. But a great deal of scientific and engineering rigor went into this project well before the first turbine was even built.
This project is one of our only projects in Canada where we've had to drive piles for our foundations. Most of our other projects, because of the geology and the soil conditions, don't require pile driving, but North Kent did.
That's because the area is characterized by a regionally extensive deposit of very soft soil, sitting on top of the Kettle Point bedrock formation, which extends from Lake Erie to Lake St. Clair and Lake Huron.
Because of that uniqueness, we've done a lot of studies and we've done a lot of geotechnical work to make sure that we understand what's going on and make sure that we're developing and constructing properly and responsibly.
As part of that due diligence, the developers hired two of the country's leading independent qualified consulting firms, Golder Associates and AECOM Canada, to conduct geological and hydrogeological surveys as part of the renewable energy approval. Still, some community members expressed concerns, and that approval was appealed.
Questions were related to the idea that the wind turbines and their construction would adversely influence groundwater wells. So we put together a multi-specialist team to try to tackle those questions.
Dr. Storer Boone, a geotechnical engineer at Golder Associates with over 30 years of underground engineering experience, addressed those early concerns.
When we got involved, we looked at these issues that were raised during the appeal, looked at MOE water well databases, vibrations, hydrogeology, geotechnical engineering, geochemistry, radiological sciences, to assess whether it would or would not have an effect on the water wells.
Golder's early conclusions were clear. Construction and operation of the turbines would not adversely impact local water wells. It also found no plausible way fine rock particles could be transported hundreds of meters from turbine locations to water supply wells. The appeal was soon settled, but questions lingered, so Dr. Boone and his team set about doing a more robust test program in March of 2017 that consisted of driving a single pile at two different sites.
Okay, so here we are at about 10 meters from where the foundation piles were driven. And as you can see, we've got the instruments located at 10, 30, and 50 meters away from where the piles were to try to measure the diminishing vibrations as the distance increases.
Ground and surface vibrations were monitored at the two sites, going all the way into the bedrock, and those findings were compared to other research and available science on how vibrations travel.
They confirmed the pattern of diminishing magnitudes with increasing distance, both at the surface, in the soft soil that's beneath the surface, and in the bedrock that's down deep.
Again, the results were conclusive.
The vibrations propagated and diminished over distances and within expectations, I would say. And that the work shouldn't have an effect on water wells at large distances in the neighborhood of 500 meters and more.
That due diligence didn't end there. As part of the conditions of the renewable energy approval, Jason Murchison, director of AECOM Canada's geosciences practice in Ontario, devised a well water baseline testing program.
In doing those baseline programs, it's vital to the assessment of potential claims or reports of impact because it provides us a prior to an existing baseline condition at that property. What was the water quality like prior to start of construction?
The results?
It varied. And a lot of that is based on the well's construction, well's age, a number of factors. So it varied across the board from very good water quality to some quite poor water quality.
In addition to the monitoring of those wells, once construction started, Dr. Boone and his team set up vibration monitoring systems at the turbine construction sites themselves.
The turbine sites were divided up into clusters, groups of turbines. And for each one of the clusters, we had 2 participating water well owners. We attended their property and set up vibration monitoring systems on their wells and the well casings, and then also monitored at the turbine construction sites.
In all, over 1,700 continuous hours of vibration monitoring of deep well casings at distances between 570 and 4,000 meters from turbine foundation were conducted. What Dr. Boone found was that background conditions like traffic actually caused more vibrations.
So here we have a few vehicles driving by that we pick up off our hand notes that you see here. This identifies when the pile driving was done. We did this for many different records. Again, where we've got a car driving by, we've got the pile driving in here.
Standing next to his own well, Doug Smith, a local landowner who is hosting a turbine just over 500 meters from his home, says that is exactly what he experienced.
We get a lot of agricultural traffic here. You get a lot of tractor trailers loaded with 45 tons of grain, and the road's got a few bumps in it. And when they hit those bumps in the house, you can feel the house vibrate. Certainly I feel those vibrations far more than I ever felt anything connected with pile driving. I could hear the pile driver from this distance away. I could hear it banging the pipes in, but certainly standing here you felt absolutely nothing. There was no vibration felt at this point.
With pile driving having been completed, as the project moved into the construction phase, out of the hundreds of wells in the project area, 16 complaints were lodged about sediment in well water and reduced flow rates. So Jason Murchison and his team at AECOM set about looking at those complaints, one by one, comparing the results to earlier baseline testing.
In some senses, we actually saw an improved water quality versus what we saw during the baseline assessment. But ones where we did see any kind of net change in it, it appears to be a local issue related to pumping systems, well conditions, or water treatment equipment.
Some of the well issues observed by AECOM included buried well heads and lack of screens at the bottom to filter out particulates.
Where we saw potential issues, we provided recommendations for those property owners to have their wells, their pump systems assessed by a professional, a well contractor.
After full investigation of all complaints, AECOM and Golder both concluded that conditions associated with those complaints were not related to construction of the turbine foundation and instead stem from well issues that likely predate the project.
I'm probably closer to the pile driving than anybody that has complained that their well has been, destroyed by pile driving. And I've had zero issues. My water is exactly the same today as it was a year ago.
Based on our assessments and based on how the nature of the work that has been completed, it leads you to a conclusion that that there isn't a mechanism for impact that we can see.
The Ministry of the Environment and Climate Change concurred that the complaints had been addressed.
This has been a Smith farm since 1861, and there's no way that I would jeopardize my family's health and safety for the sake of having a wind turbine on my property. If I'd have ever thought for a minute that this could cause trouble with my water, there would probably have been no turbine ever built on my property.
With the turbines now up, due diligence on the project is far from over. For the next 3 years, data will be collected from a series of mock wells that have been drilled to simulate wells in the area.
Here we have our instruments for one of what we're calling the mock wells. We have the well casing here, which goes down to just to the top of the rock. And then in the rock, we've cemented some vibration monitoring equipment. And you can see on this side of it, we have our accelerometers, which measure also the movements of that well casing itself. The idea behind all this is that we'll be monitoring vibrations in the bedrock and at the top of the well casing. compared to, again, to the distance away from the turbines.
When you look at the science that we've been conducting, the due diligence as well as the monitoring out in the field, it's pretty conclusive that our construction activity and the activities of the wind farm has not, cannot, and will not affect the quality of water and water wells. You know, from our perspective, we've done everything that we can and more. Being open, being transparent goes back to fundamental pattern values. Being part of the community, being open is very important to our company.
For Doug Smith, it's all part of the bigger picture.
I just see the future of energy production in the world, not just Ontario, but the world. The world is embracing renewable energy, and I'm thrilled to be part of that revolution. I wouldn't want to be on the sidelines at this point.